Okay, so last question in this test part, A4. I think we'll find this on textbook page 140. Okay, so let us write down by reading the question. From the question as we read it, we see here it's mentioned since the motor car of mass 1200 kg is moving along a straight line, so straight line motion with a uniform velocity of 90 km/h. So here, as we read the first sentence, we get this one. Obviously M is 1200 kg. That is find the mass of the vehicle. With 90 km means initial velocity u, 90 km/h. But this is not SI unit, so we need to change to SI unit: kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. So we need to change this kilometer to meter. 1, 2, 3 places to the right. So we have to multiply this 90 by 1, 2, 3, 0. 10, 10, 10. So 10 into 10 into 10 is 1000, right? So 1000 multiplied to 90 is 90,000. Then kilometer therefore will change to meter. Then here hour needs to be changed to second. So how do you do that? Nothing is here means 1 hour is there, so into, now we know time is here hour, minute, and second. So we're changing the hour to second. Big to small, 2 places. 1 place is 60, right? 1 hour 60 minutes. 1 minute 60 seconds. So 2 60s. So double movement, so 60 into 60. Then the hour changed to second. That's how we change the km/h to meter/second, which is the SI unit. So these two can cancel, and 6 ones are 6, ones are 6, 3 in hand, 6 5s are 30, 0, and 6 ones are 6, 6 2s are 12, 3 in hand, 6 5s are 30. So this will be 25 like this, or you bring it up, then it will become second to the power minus 1, like your textbook is doing, which is not necessary. You can do like this also. Then next statement, and the next part of the question is saying its velocity slowed down. So they're obviously applying brakes, so slowing down to 18 km/h in 4 seconds by an external unbalanced external force. So this means initial is 90 km/h, slow down to 18 means there is a final velocity v equal to 18. So we can write here initial velocity. Okay, so 18 km/h. So let us change it to SI unit. Kilometer to meter means 3 zeros as we have done here, divided by 1 into 60 into 60. So maybe we can write it more properly. So 1,800 by 1 into 60 into 60, then meter/second. I'm not explaining because we have shown it here. Okay, so 0 and 0 cancel. 6, this 2 0 cancel, sorry. So let us cancel this 2 0. 6, then 6 ones are 6. Then 6 3s are 18. 6 zeros are 0. Then 6 ones are 6. 6 5s are 30. So your V value will come out as, don't need this, so I can have it on. 5 meter/second is the final velocity. We're given all these values. Now we need to find one. Let us see. First, calculate acceleration. So A is question mark. The acceleration of the vehicle is what we have to find. Then next here, change in momentum. So next, slowly do that and find the magnitude of the force required. F is equal to question mark is the force required to slow the car from 90 to 18 km per hour. What force was applied on the brakes? That's what it means. So A, let us start first, then momentum will do after this. Okay, so here, since we know V equal to U plus AT from motion equation, so A will be equal to, okay, here, A will be equal, okay, you can do like this also, sorry. AT is equal to V minus U, this one shifted. Then V minus U divided by this T will come down. A is like this. So that will be equal to V here, as you can see, 5. So 5 minus U is 25. So we write that. And T is, I forgot to write here TC 4 seconds. So we just write here T in between. 4 seconds is the time taken for the car to slow down from 90 to 18 km per hour. So T is here 4 seconds. This is A. Then we write here 5 minus 25 is, and here common factor, meter per second can come out of the bracket like this. Okay, so here meter per second equal to A. Then 5 minus 25 is minus 20. Okay, minus 20. Let me write it properly. Minus 20 meter per second. Wait for this one. Shift this one up to the numerator, then second to the power plus 1 will become second to the power minus 1 divided by this 4 is equal to A. So as we proceed, 4 5 is 20, so we're going to get A equal to minus 5 meter per second to the power minus 1 is to the power minus 2. So this one let us put as equation number 1. Then next we need to find change in momentum. So let us do that. Here we know that the change in momentum formula, we've been doing this previous some sums also. Change in momentum is final momentum minus initial momentum. This is the formula, right? So we write that down, and here we know momentum formula is mass into velocity. So mass of the vehicle into final velocity, because final, minus mass of the same vehicle into final initial velocity U. So m common we can bring out, then V minus m gone out, so U. 1200 kg is the mass of the vehicle. V is minus 5. Please remember here we wrote. Then U is here minus already, and U is, I think here see 25. So this is done, and meter per second common factor can come out, divided by, or not divided by, sorry. So that is it. So that will give you here 1200 kg minus 5 minus 25 is minus 30 meter per second. So value for change in momentum is plus and minus minus 3 2s are. Okay, so yes, so this one will be final velocity. Sorry. Initial velocity is not minus 5, that is acceleration. As you remember 5, so this will be not minus 30 plus 5, and minus 25 is minus 20. Plus and minus 12 2s are 24, and here 000 1230 kg meter per second, which is the unit of momentum. So that is your answer for change in momentum, equation number 2. Right, so finally we have to find, go back to question, force required to stop the vehicle, right, or to slow the vehicle. Also calculate the magnitude of force required. So we know that what's written there, F equal to M into A. Mass of vehicle is 1200 kg into A, just now we got here, minus 5 meter per second square. And you can write here since using equation number 1. Then you're going to get here, minus into plus is minus. 12 5s are 60, remember that, and 2 more 0. Here kg meter per second square, which is simply minus 6000. This base unit of force can be changed to Newton. Put this one as equation number 3. All the answers we got, we'll write in the sentence form the final answer. So therefore, go back to question, calculate acceleration. So acceleration A is equal to here minus 5 meter per second square, as you get this one by using equation number 1. Okay, then let's write here which is clearly negative. Therefore, you can write the final answer if you want. Acceleration is 5 meter per second square, comma, because it's negative, in the direction opposite to the motor car, opposite to the movement of the car, original direction of the motor car. First answer. Then second answer is change in momentum. So you just write here, therefore change in momentum, as you can see here, we have calculated and found out to be minus 24,000 kg meter per second. We can write your since using equation number 2. So this is your second answer, right? Then finally, calculate the magnitude of force required. Therefore, okay, since here F equal to minus 6000 Newton, as you get this one by using equation number 3, comma, which is negative. F is negative, therefore force required, we can write, is 6000 Newton, comma, in the direction opposite to the motor car. You can write like that because negative, right? Now we have been doing by starting, let the vehicle be moving from left to right. It's good to do that also, but once you understand, you can do directly like this also without using that left to right kind of concept. Okay, so that's fine. That concludes this test portion. Now I can go and give the test. Okay.